Hi guys, today we're going to be talking about erosion, and we're going to leave deposition for a separate subject. So we'll just focus on erosion for today. Now, again, this is one of those lessons where you're going to want to take notes and literally like take a piece of paper out and start writing some stuff down as we go through some of the things that are in this presentation, okay? And you can pause it if necessary when you're needing to write something down. Now, I want to just go back to a picture that we saw earlier with our weathering topic. Now, obviously, you guys might remember this is Teganic Falls, and Teganic Falls is a really awesome place to go visit because of, well, it's just beautiful. And also you see some frost wedging going on there in the wintertime, which is pretty neat to see. And then the contrast with that in the summertime. Now, the frost wedging is breaking off those pieces of rock, and that process we call weathering, and we talked about that. But all this rock that falls down below, obviously it'll stick around for a little while, and you'll see some piles of sediment at the bottom of the base of the cliff there. But if that kept doing that for years and years and years, it would just pile up and never go anywhere. So it has to go somewhere. That transport of that sediment is going to happen by this water. So this water eventually leaves through this valley and exits and comes out, and you can kind of see in the background, this is the valley that it's coming through. This is the gorge of Teganic Falls. Teganic Falls is way back here. And this photo was taken from an airplane over Cayuga Lake. And you can see all of the sediment after a lot of rain happened. All the sediment that's in the stream, in the river, flows out into the lake, and you can see it entering into the lake out here. So all that transport of all that sediment happens typically when you have a lot of rain or after a lot of snow melt in the springtime, which you can see this photo was taken back on April 5th, 2005. And you can see it's getting deposited or sent way out into the lake out here. And this is all really small sediment, like clay-sized sediment, silt-sized sediments, really makes that river really cloudy and mucky looking. Okay, so this transport of sediment is what we're talking about. And this happens all across New York State. This is Letchworth Falls State Park, which is a pretty place to go visit as well. This is one of my favorites, Treeman State Park, which is down in Ithaca. Really nice place to visit in the summertime. It's a really cool hike. So the same thing is happening there. All the sediment that's being taken out of the sides of these waterfalls is being transported down through the streams and out into the lakes. This is a well-known, I think, place that you all know. This is the Grand Canyon out in Arizona. Everybody that has ever gone there always tells me that, you can't really describe it with a picture, or you can't describe it with words. It's just stunning. It's so large of a place to go see. So this is, again, transporting all the sediment out of this valley, out through the Colorado River, out into the Pacific Ocean eventually. And that transport process is called erosion. So here's a definition. I would write this down. Erosion is the transportation or the movement of sediments by water, air, glaciers, or gravity. And again, it's not the breaking down of the sediment. That's the weathering part of this. We're talking about moving it. Now, obviously, in the process of moving sediment, you're going to have a lot of weathering take place, which we kind of talked about with abrasion. That's a really big one, right? But erosion is just referring to the transport of that sediment through one of these means. Now, the causes of transport are called often the agents of erosion. The agents of erosion are water, wind, glaciers, and gravity. And it's kind of cool. It sounds like agents, like a secret agent.
Bond. James Bond.
Right? Now, water is the most important of all the transport processes. Water is all over the globe. Obviously, it's really good at carrying sediment off of the land out into the oceans. And so it's responsible for most of the transport of sediment from the land. You can see here a picture of the Mississippi River Delta, which is down in the Gulf of Mexico. And it carries about 6 tons of sediment out of the Mississippi River per second into the Gulf of Mexico. It's crazy. There's a lot of sediment being deposited out here. It's kind of like that previous picture we saw. And I couldn't find a 6-ton picture, but there's 8 tons of sand. And imagine that, like every second coming out of the Mississippi River. So it all piles up here at the end of the river. Okay, and then it gets washed away by currents in the Gulf of Mexico. So let's just talk a little bit about water and how it transports the sediment. We'll start with the agent of water. Okay, so erosion by water. This is how it gets transported within a stream. There's all these different methods of transport: solution, suspension, flotation, and what's called the bed load. Now this picture right here, if I were you, I'd sketch this picture and like put all these different terms right into the picture. You can see all these different ways of transporting. The definitions aren't necessarily as important as this picture is, just knowing where this happens. So the bed load are all the sediments on the bottom of the stream, okay? And you can see the bed load is down in the bottom of this definitions here. It's all the denser, larger pieces that can't get picked up by the stream unless the stream's going really, really fast. We have what's called the suspension. Suspension is all the stuff that's in the stream, that's getting transported in the stream, that is visible, that you can see, right? And that would especially be true with like a really cloudy looking murky river. That's all the sediment that's in the stream that makes it look like that. That's the suspended load. So it's stuff like silt and sand perhaps would be up in the suspended load. Now there are some things that are dissolved in the water. We call that the solution. Dissolved just means you can't see it. It's microscopic in size and it's really small. So salts and things that come off of a chemical weathering process, those would get transported in the solution load. Now along the bottom, kind of cool, the stuff that's along the bottom of the stream is abraded, right? We talked about abrasion. And you'll see that it kind of bounces along. We have these things that are what we call saltation, which is where it like jumps. You might know that the Spanish word saltar means to jump. So the saltation, you'll see these jumping little pebbles along the bottom. Some of them will roll along. Some of them will kind of track. In other words, they'll just kind of slide along the bottom. But all that bumping along the bottom of the stream is causing abrasion, is causing weathering to happen to make these smaller and smaller pieces. Okay, so stream transport happens within one of these ways, again, depending upon the size of the sediment. I just want to show you this video again. You can see the streams carrying sediment along the bottom. It's all kind of moving along, saltation and traction, all these methods of moving those bigger sediment along the bottom. Some of the stuff is dissolved in the water and some is being carried, the smaller sediments being carried in the water up here. You can kind of see in this view here, all these different sediments moving along the bottom. A lot of sediment that's larger is along the bottom here, okay? But all the smaller sediments up here suspended within the water column. Okay, just to show you guys that same view that we saw before. Now this graph is in your reference table, and this is kind of the big takeaway from today's lesson, is the transportation methods for different size sediment. And we'll be talking about this graph a little bit more in the classroom, so I won't spend a ton of time here, but just go to page 6 of your reference table and you'll see this thing. Now, what I've done is I want to point out that there's different size sediment along the right-hand side here that I think I've mentioned before. These different sizes correspond with particle diameter over here in centimeters. So clay is super tiny stuff, microscopic size particles, 0.0004 centimeters or less. Silt size is a little bit above that. Sand size, which you're familiar with, then pebbles, then what we call cobbles, and then boulders are at the top, anything bigger than 25.6. Now what this is basically showing is, in order for a stream or a river to transport these sediment sizes, it has to go faster and faster and faster, okay? So like a slow moving river will carry clay, no problem, and silt. But in order to carry larger stuff like pebbles and cobbles and boulders and move those along, it needs to be traveling at a faster velocity. Higher velocity over here on the right-hand side means transporting more stuff. Now, let's go with an example question. Let's say that the stream is going 100 centimeters per second. So follow this on up 100 centimeters. That means that that stream, hit the line right there, can carry pebbles, and it can carry sand and silt and clay, anything less than it as well. Okay? In order to carry boulders, it would have to be going faster than that. So that's kind of the idea with this graph, and we'll talk about this more in the classroom. Now, one thing that might be helpful for you is just coloring this thing if you want to do this. I colored mine like this so you can see those different sections of different size sediments along there. But again, this diagram is something that's important. It's related to the idea of how a stream carries the sediment in these different ways. Okay, so that's the page 6 reference table that I just wanted to mention, and we'll talk about this more as we go along. Now, This is actually called the Hulstrom diagram. It's a different way of setting it up. It's the exact same thing, but I just wanted to mention that. Another transport agent, or another agent of erosion, is wind. Wind is able to carry sediment that's typically sand size or less. So if you go back to this diagram here, sand size is anything less than 0.2 centimeters. So the velocity of the air typically doesn't get high enough to carry pebbles through the air. Thankfully, you wouldn't want to get knocked with a pebble in the head, right? But sand size, silt size, clay size, the wind can typically carry that. And so we're talking about sediment that's typically sand size or less. In order to carry larger particles, it's got to go faster. Same is true with the water, right? So water and wind have some similarities there. Now, the wind will carry these sediments and will, in some ways, abrade surfaces. We talked about wind abrasion. So if sand is colliding with like the side of a cliff or a boulder that's embedded in, let's say, the ground in a desert, you'd see some abrasion happening to that surface wherever the wind is coming from. Especially true in deserts where you have big open areas and beaches where you have a lot of sand. Dry, arid climates will have this happen. This is a picture of me on top of what's called a ventifact. This is right along the Pacific Ocean up in Washington State. You can see along here, these are all kind of chewed away, this rock here, by the sand that's getting picked up and driven against the rock here. And also on the opposite side, the sand kind of gets pelted against the rocks on the opposite side where the surf is coming in and the tide comes in and is just smashing against these rocks and carrying all that sediment with it and just kind of wearing away and smoothing away the sides of these rocks here on the beach. There's a really cool tide pool back there where there were some like sea anemones and stuff and sea stars, which was really neat. Anyway, so those are called ventifacts. Not a necessary thing to know, but I figured I'd point that out to you. Here's another picture of a ventifact in a desert, right? And you can see like all this got worn away by the sand getting picked up and driven against that rock, that boulder. Desert pavement is sometimes found where you only have like the larger pebbles left over, so the sediment gets carried away, the smaller stuff, the clay, the silt, the soil even, and that's happened during the Dust Bowl era. All that plowing and incorrect farming methods took away all the soil from the landscape. Anyway, so that's desert pavement. I just figured I'd mention that. It's a good vocab word. All right, erosion by gravity. So another agent of erosion here. Gravity erosion is sometimes called mass movement. It's another way of giving it a different term. It's the motion of soil and rock down a slope due to gravity only, okay? And this is influenced by things like precipitation amounts and the landscape. Now, there are different types of mass movement, what we call a landslide, which you're probably familiar with, where it's just soil and the top surface of the rock that are sliding downhill. That can be influenced by like lots of rain, or after a wildfire, you kind of strip away the vegetation, which will help that happen. We'll talk about that a little bit later on in the year. What's called a slump, that's kind of a slow moving creep of land downhill, just along on a hillside. And avalanches, that's typically we're referring to snow and ice on the side of a mountain. But in the process of moving this stuff downhill, which happens pretty rapidly, it will carry all size sediment down the hill from one location to another location. So technically, we are transporting sediment from uphill to downhill. Okay, so that is another agent of erosion. Not long distances, just down the slope. All size sediment, doesn't matter. It could be big, huge boulders like that, right? Or it could be tiny little stuff too. It's a funny sign there next to that rock, which is kind of ironic. Anyway, I'm glad that nobody was injured in this. But there you go. You can carry all size sediments. All right, last type are glaciers, another agent of erosion. Glaciers are large masses of ice that flow over land. Don't mistake them with icebergs. Icebergs are ice that floats in the water, like, iceberg dead ahead, right?
Iceberg, right ahead! Thank you. Iceberg, right ahead! Understand!
But glaciers are large masses of ice that flow over land. And this drastically changed our landscape here in New York State. We're going to be focusing on glaciers as a separate study, so I won't talk about them too much. What I just want to mention is the fact that glaciers can drag and push and basically destroy a landscape and push all the sediment out of the way, almost like a snowplow pushes snow down the street. They cause all kinds of things to occur, lots of different landscape features, which we're going to be looking at, but it pushes all different size sediment, and just be aware, it's kind of like gravity in that sense that it carries all sediments. You'll see striations sometimes in the landscape. Striations are just scratches in the bedrock. I mentioned this when we talked about Alfred Wegener and some of his evidence of movement of continents. I took this picture standing on top of a rock which was polished by glacial ice. It was cool. It was really smooth and shiny looking rock. You sometimes find these up in the Adirondacks too. This is a picture of a glacier up in Alaska. I forget the exact one. It might be Mendenhall, but don't quote me on that. This glacier, you can see it's huge. It's a large mass of ice, and as it moves downhill, down out of the alpine area up here, it's just pushing all this sediment. These glaciers will calve, which just means they break off and fall into the water, and then you'll have icebergs floating away from that. Okay. But this is a really good mechanism for transporting sediment. You can kind of see where this person is standing. There's all this sediment that's built up over here, and that's all unsorted and like kind of unorganized. It's just moved by this glacier. It doesn't matter how big the boulder is. It'll transport it really far distances. Anyway, so that's those are glaciers. And you can see here, this is kind of a time lapse image. So you can see 21,000 years ago, all of Canada was covered, including into New York State. So New York State was covered by a glacier. And then that glacier retreated all the way back to Greenland eventually, and now it's only on Greenland. And currently it's actually retreating from Greenland just due to climate change. But you can see, obviously, this glacier pushed all the sediment down into this area, down into the United States. And so we'll be talking about that a little bit later on in the year. Okay, and this is another picture to show that. One last thing, I just want to show you four different sediments, 4 different rocks, and transported by different means, or in some way changed by different means. We'll start with actually letter D, the stream, right? The stream, notice, remember, it's rounding it out, rounding those corners out, kind of like the sugar cubes in the lab. Nice round, smooth stone, due to the fact that it's being abraded in the bedload of a stream. This is a glacially eroded rock due to the fact that you see these scratches, striations in it, kind of polished off as well. This is a wind eroded rock. You can see all these little pock marks in it. There's little holes. Those are due to the sand that's like pelted against that rock, kind of chiseling it away. And there's gravity. It's just kind of boring rock. It's just angular. Notice no like rounded sides to this thing. Just broken off the side of a hill and transported downhill. So not a lot of weathering has taken place here. Okay, so just to kind of summarize all those things. So that's erosion. What we're going to be talking about next is deposition, but I'm going to save that for a separate presentation. So again, take those notes, and hopefully you guys got something out of it. If you have any questions, just let me know.